Since fractional exponents are defined using radicals, one can always switch from radical notation to fractional exponents and vice versa. As an example, let's write using radical notation. Well, we have 8xy to the 1/3 power. I can rewrite this as the cube root of 8xy to the first. The denominator tells me the root to take. The numerator tells me the exponent. Now, I did not say simplify, so I'm going to quit there. All I did was say write using radical notation. I have 4ab to the negative 5/4. Excuse me. A negative exponent says to take the reciprocal. So it would be 1 over 4ab to the positive 5/4. 1 over 4ab to the positive 5/4, which now, writing it as a radical, would be 1 over the 4th root of 4ab to the 5th power. The denominator tells you the root to take, the numerator tells you the exponent. We can also go the other direction. Write using fractional exponents and simplify. You've got the cube root of 8x to the 6th y to the 9th. Well, what I can do, I can say my exponent here is 1, so I can write that as 8x to the 6th y to the 9th raised to the 1/3 power. The denominator is the index, or in this case, the index of the radical is your denominator of the fraction. Your exponent is the numerator. Now, if I have factors inside parentheses, the exponent outside the parentheses applies to each of those factors. So I have 8 to the 1/3, x to the 6th to the 1/3, y to the 9th to the 1/3. Well, 8 to the 1/3 is the same as the cube root of 8, which is one of 3 equal factors whose product is 8, so that gives me 2. To raise a power to a power, I keep my base and multiply the exponents. So I'm multiplying 6 times 1/3. If I multiply 6 times 1/3, that's the same as 6 over 1 times 1/3, which is 6 over 3, which is 2. And to raise a power to a power, I keep the base and multiply the exponents. 9 times 1/3 is 3, because that's understood to be 9 over 1, so I get 9 over 3, which is 3. I'm going to give you a note to keep us from running into difficulty with the real number, with radicals not existing. While working with radicals, we will assume that letters represent positive real numbers. So when you have letters that you don't know what they stand for, you could end up with the square root of a negative or something. What we're doing is we are assuming that the letters represent positive real numbers, and we're going to work with it from the positive standpoint only. Well, let's look at another example. The square root of x to the 4th y to the 5th raised to the 3rd power is equal to x to the 4th y to the 5th raised to the 3/2 exponent. This index is understood to be 2. So the index tells you the denominator, the exponent tells you the numerator. The exponent 3/2 applies to both bases. So we have x to the 4th to the 3/2, y to the 5th to the 3/2. Now to raise a power to a power, I keep the base and multiply the exponents. So I'm going to get x to the 12 halves, y to the 15 halves. 4 times 3 is 12 over 2. 5 times 3 is 15 over 2, which is going to give me x to the 6th, y to the 15 halves. I'm going to give you a theorem now, improve that for you. Let x be a real number with x greater than 0, and let m and n represent non-zero integers. The nth root of x raised to the m power is equal to x to the m divided by n. In other words, to take the nth root of a power, x to the m power, I can divide n into m. It's exponent m divided by the index n. Well, let's look at the proof of that. The nth root of x to the m is the same as x to the m raised to the 1 over n power, because that's understood to be 1 over there. The denominator tells me the index, the exponent gives me the numerator. Now to raise a power to a power, I keep the base and multiply the exponents. So I'd have x to the m over 1 times 1 over m. Or if I multiply, I'd have x to the m over n. Now that theorem makes it real easy to evaluate certain powers. Example, if we have the cube root of x to the 12th. The cube root of x to the 12th is x to the 4th. 3 goes into 12 4 times. Just divide the index into the exponent. The 10th root of x to the 50, y to the 20th would be x. 10 goes into 55, 10 goes into 22. The 5th root of 32, x to the 10th, y cubed, is going to be 2, because the 5th root of 32 is 2, since 2 times 2 times 2 times 2 times 2 is 32, and then it would be x, 5 going to 10, 2, 5 going to 15, 3. This completes tape 119.